Hey everyone, this is the second lesson from this unit. So we're looking at the trigonometric ratios for angles. So to start, we're going to look at the special triangles. I know it might have been a while since you've looked at these special triangles. So we're looking at these exact trigonometric ratios. So our first special triangle is we're going to have an equilateral triangle. So equilateral triangle has to have all sides the same, all angles are the same. We're used to these being all 60-degree angles. Now that we're talking about radians, remember 2 radians was a full circle, 360 degrees. So half a circle is 180 degrees, or pi radians. 60 degrees, that's a third of pi. So all of these angles that last year you would have talked about being 60 degrees are now pi over 3 radians. And for this special triangle, we like to say that all sides are 2 units, and that's because we're going to cut this triangle in half. And when we cut that triangle in half, we have, look at this left half here, so we have a 90-degree angle, or in this case, a pi over 2 radian angle. This was pi over 3, and now this pi over 3 that got cut in half is pi over 6. So what was before, we had 60 degrees and 30 degrees. Now talking about radians in grade 12, we have pi over 3 and pi over 6. This side that we cut in half now is 1. This was 2 because this is still our original side of that equilateral triangle. And then we're going to use Pythagorean theorem. Our hypotenuse squared minus this side squared, so 2 squared minus 1 squared. 4 minus 1 gives us 3. So this side has to be the square root of 3. So in case we forget it, that was like our c squared minus a squared equals b squared. 2 squared minus 1 squared equals b squared. 4 minus 1 equals b squared. 3 equals b. Square root of 3 equals b, not b squared. So our primary trigonometric ratios for these 2 angles, we're going to get sine, cosine, and tangent of, let's make this bigger for you. I got lots of paper here. Sine of pi over 6, cosine of pi over 6, tangent of pi over 6. And remember, way back to grade 10, SOHCAHTOA. So sine of pi over 6 is opposite over hypotenuse. Our opposite is 1. Our hypotenuse is 2. Cosine of pi over 6. So we're adjacent over hypotenuse. Our adjacent is square root of 3. Hypotenuse still 2. And tan is opposite over adjacent. So tan of pi over 6, opposite is 1. Adjacent is square root of 3. So we have these 3 ratios for pi over 6. And then we can also do them for pi over 3. Cosine of pi over 3. Tangent of pi over 3. So sine of pi over 3, opposite over hypotenuse, square root of 3 over 2. Adjacent over hypotenuse, 1 over 2. And now opposite, square root of 3 over adjacent. is 1, or we can rewrite that as just the square root of 3. So these are two of our angles that we're going to use for these exact trigonometric ratios, two of our special angles. The third special angle, which we get from a different special triangle, an isosceles triangle, this is the one that would have been a 45, 45, 90 degree triangle last year. So now 45, that's a quarter of 180. So both of these sides are pi over 4. Both these angles are pi over 4. We can say this is 1 and 1. And now 1 squared plus 1 squared, so 1 plus 1 equals 2. And that means c is going to be the square root of 2. So our hypotenuse of this triangle is the square root of 2. And we're going to see what is sine of our angle is pi over 4, cosine of pi over 4, tangent of pi over 4. Sine of pi over 4, doesn't matter, we can pick either one. Opposite over hypotenuse, 1 over the square root of 2. Cosine, our adjacent's also 1, so we get 1 over the square root of 2. And opposite over adjacent, 1 over 1, or 1. There's our nine major special angles that you would have talked about last year. On the lesson that's posted, there's also another look at this special triangle here, which you may or may not have talked about last year. That's okay. But in general, if we look at a triangle with a very long leg and a very short leg, and if we say this leg of the triangle is 1, our hypotenuse is very close to 1. The longer we make this side, if I keep stretching this out, this is going to get closer, or the word we've been using this year, especially for asymptotes, is this is going to approach 1. The longer and longer we stretch this, the more this and this are basically the same. This angle here, if I keep stretching and stretching and stretching, this length stays the same. This angle is going to get closer and closer to 0. And if this angle is getting closer to 0, this is a 90 degrees. This angle here is going to get closer and closer to a right angle. It's going to get closer and closer to pi over 2. So we can use this kind of rough approximation to give us some more, just reinforce some more of our exact trigonometric ratios that we use. So if we look at sine of 0, this is getting closer and closer to 0. Our opposite stays the same. Always going to be the more this side is bigger than this side, the more our hypotenuse is way bigger than this. Basically, it approaches 0 over 1, or 0. This side divided by this side becomes 0. If this angle comes in, we have no more opposite side there. Cosine, if we get this angle all the way to 0, now our adjacent and our hypotenuse are the same thing. So we if they're both 1 or if they're both some other number, that ratio is still going to be the same, which is just going to give us 1. And tan of 0, our opposite's getting closer and closer to 0. Our hypotenuse is getting closer and closer to 1. So our tan of 0 also approaches 0. That's what our calculator will tell us too. If we see sine of 0, gives us 0. Cos of 0 gives us 1. Tan of 0 gives us 0. We can also look at this angle here, our pi over 2. Look at sine pi over 2, cosine pi over 2, tan pi over 2. Sine of pi over 2, our opposite is 1. Our hypotenuse is approaching 1. It's getting closer and closer to 1. So if this was actually pi over 2, it would be 1. Get 1 over 1 is 1. Cosine, we're getting closer and closer to 0. As we approach pi over 2, our hypotenuse gets closer and closer to 1. So 0 over 1 is going to give us 0. And then our tan, our opposite over our adjacent. This is getting closer and closer, or this is 1, sorry, opposite is 1. Our tan gets closer to 0. So 1 divided by 0, I guess I shouldn't put an equal sign. This one is undefined. So if we switch the calculator to radians, so we know because now there's an R instead of a D. If you need help on your own calculator, let me know. If we switch that into radians, and we see sine of pi divided by 2, that's 1. Cos of pi over 2 is 0. If we try to find what tan of pi over 2 is, it's going to give us an error. That's because it's undefined. That's backing up what we just went through. So these special angles, so we're going to use our 0, our 30 degrees, or pi over 6, what we're used to being 45, or pi over 4, pi over 3, or what was formerly known as 60 degrees, and pi over 2, they can all be used as reference angles from now on. We know what those are exactly for all 3 of these trig ratios from now on. So if we're asked, find the primary trig ratios, so primary trig ratios at sine, cos, and tan, we're going to do that for 2 pi over 3 to start. So 2 pi over 3 . 2/3 of a pi, we're getting 2/3 of the way to halfway around the circle. Or we can think of it as 1/3 of a pi away from that halfway around. And so if we remember from last year, because you would have done this with degrees, we always are going the closest way from the x-axis. So if we need to get all the way to this line here, the closest way is to go from this side of the x-axis, and that is going to be our related acute angle. I'm hoping your teachers last year used that word. I'm assuming they did, but that's what I'm going to call it from here on out. That angle from the x-axis, the shortest way from the x-axis to the angle we're looking at, we're going to call the related acute angle. So we can use that if we're looking for sine of 2 pi over 3. We can use that to find an equivalent expression. The other thing to remember is our where are we positive? And so we use this cast mnemonic device. So cosine's positive in this quadrant, everything's positive, or all are positive in this quadrant. Sine's positive here, tan's positive here. Sine were positive, and then our related acute angle was pi over 3. So this is equal to sine pi over 3. If we flip back and look, sine pi over 3, oh, that was root 3 over 2. We're going to have to brush those off and commit those to memory, or at least know how to draw these related acute angles, or draw these special triangles. I guess you don't really need to memorize them because I'm just giving you assignments at this point in time. But if we do end up back in school writing exams, that will be something I will ask you to know how to come up with on your own. Cosine of 2 pi over 3. Cosine in this quadrant, it's not positive, only sine's positive there. So it's going to be a negative cosine. And again, our related acute angle is pi over 3. Cos of pi over 3 was 1 over 2. So this is going to be negative 1 over 2. And last but not least, our tan. Tan of 2 pi over 3. Again, we're negative tan of 2 pi over 3. Sorry. We're negative, and we put in our related acute angle, which was pi over 3. Tan of pi over 3, our opposite, was root 3. Our adjacent was 1. So tan of pi over 3 is root 3, and we had a negative sign in front. So that's going to equal negative root 3. So this, we want to brush off and remember how to do. We want to remember how to come up with these equivalent expressions. So relating whatever angle we're looking at with its related acute angle that we know from our special triangles. Look at another example here. So we'll look at the angle. Let's pull up our sheet again. 7 pi over 6. 7 pi over 6. That is 6 pi over 6 would be halfway around a circle. So it's just over that to here. That is 7 pi over 6. And if this is 6 pi over 6, that means to get back to the x-axis, our related acute angle is going to be pi over 6. So our related acute angle is pi over 6. Sine of 7 pi over 6. We're in the bottom left quadrant, so only tan is positive. So our sine and our cosine are negative, tan is positive. And all of these are for the related acute angle of pi over 6. Sine of pi over 6 was 1/2. So this is going to be negative 1/2. Cos of pi over 6 was root 3 over 2. This is negative root 3 over 2. And tan of pi over 6 is 1 over root 3. And we stay positive. So we're going to have these 3 trigonometric ratios. 5 pi over 3 is our next example. So that's all the way around. Almost 6 pi over 3 would be a full rotation. So we're 1/3 pi over 3 away from the x-axis. So if we're looking for our sine of 5 pi over 3, cosine of 5 pi over 3, let's sharpen the pencil, tangent of 5 pi over 3. For all of those, our related acute angle is pi over 3 again, same as in part A. The only difference now is this quadrant, we're in the bottom right, that's where cosine was positive, and sine and tan are negative. So we get negative sine pi over 3. Sine pi over 3 was root 3 over 2. So we get a negative root 3 over 2. Positive cosine pi over 3. Cosine pi over 3 was 1 over 2. And it's positive. And then tan pi over 3 was root 3. So this is going to be negative root 3. There's always 2 parts in coming up with our equivalent expressions every time. We have our sine, which we know from which quadrant we're in and which trig ratio we're looking at. And then our related acute angle is which way is the closest to get to the x-axis and how far is that. So we're always going towards the x-axis from wherever the arm of our angle is. Got one more example on here. The 3 pi over 2 so 3 pi over 2, that is in degrees, like 270 degrees. Each pi over 2 is 90 degrees, so we're going around 3/4 of the way. And here, sine of 3 pi over 2, that we're just negative Sine is both negative sine's negative in both of these quadrants. So we're going to be negative our related acute angle, so how far it takes to get to the x-axis. Either way we go, it's pi over 2 radians away. And sine of pi over 2 is 1, so this is going to be negative 1. Cosine of 3 pi over 2. Again, our related acute angle was pi over 2, so it doesn't really matter what the sign is because cos of pi over 2 is just 0. Cosine is negative in this quadrant, it's positive in this quadrant, so when we meet in the middle, we get 0. Same thing with tangent. Doesn't really matter what the sign is because using that related acute angle, tan of pi over 2 is just 0. Tan's positive in this quadrant, it's negative in this quadrant. When we meet in the middle, again, it's just 0. Oh, I lied. Tan of pi over 2, sorry. Tan of pi over 2 was undefined. So cosine, can't remember if you've done graphing of trig functions in grade 11, but cosine function oscillates back and forth. So the only way it can go from being positive to negative is at a 0, whereas tangents look like this. And they have asymptotes. So they can go from a positive to a negative by way of an asymptote. So tan of our related acute angle, again, it doesn't matter which sign it is because that related acute angle is undefined. My apologies. So there was those 4 examples. And now the last 2 questions on this first part of the lesson are talking about cast being used in reverse when given our ratio to try to find angles. So we're going to look at a slightly different kind of problem here. Given cos of theta equals 1 over root 2, and we always want a range for that theta because it's a cycle, it keeps going back to the same values. Find the value of theta. So our first step, we want to find the reference angle. We want to find basically the easiest angle, that related acute angle, as I like to call it. So if we have cos of theta equals 1 over root 2, well, if we have some angle theta, our adjacent is 1, and our hypotenuse is the square root of 2, well, that's just our special triangle from before. That theta, that has to be, back in grade 11, had to be 45 degrees. Now it has to be pi over 4. So this is our related acute angle or our related angle. Sorry, our related acute angle or our reference angle. And we're going to use this to find every possibility in this domain. So from 0 to 2 pi, cosine can be positive in this quadrant, or it can be positive in this quadrant. So we can have this related acute angle or this is our related acute angle. And so this first scenario is already covered. This second scenario, we go all the way around to 2 pi. And we need to subtract our reference angle. So that's 2 pi minus that pi over 4. We want to find a common denominator, so we're going to multiply the top and bottom by 4. We get 8 pi over 4 minus pi over 4, and that's going to give us 7 pi over 4. So for this question, both theta equaling pi over 4 and 7 pi over 4 will work. Cosine of both of those gives us 1 over the square root of 2. The next question, given tan, let's do this on the back side. Given tangent, tan of theta equals negative 7 over 24. Again, our domain is theta's greater than or equal to 0, but less than or equal to 2 pi. So just our standard first rotation of a circle. What is theta? So again, we're going to find the reference angle, find our related acute angle. So tan of theta was negative 7 over 24. Well, there's no special triangle that had 7 or 24. So we're going to have to take the inverse tan. So the inverse tan of positive 7 over 24, and we're going to do positive because we want an acute angle. We want an angle that's between 0 and pi over 4, or 0 and 90 degrees. So we need first make sure our calculator is in radians. I'll post a reminder about that in the classroom because I'm sure not everyone's watching this video. So we're going to do the inverse tan of 7 over 24. So reference angle is approximately 0.28. 284, I guess it would be. But 2 decimals is okay. So this angle, this doesn't solve this because this would give us a positive ratio because we're less than pi over 4 but greater than 0. So let's look at our quadrants here. Let's find, we're going to put our related angle into its proper cast quadrant. So tan has to be negative. Tan can be negative in this quadrant, the C quadrant, A, or the S quadrant. And that would mean this would be our related acute angle, and this would be our related acute angle. So I guess maybe I should use A and B, not 1 and 2, because I've already used 1 and 2. So for our first angle, this has to be 180 degrees, or pi, minus our related acute angle. So that's pi minus 0.28, which 3.14 minus 0.28, approximately 2.86. Our second angle all the way around to 2 pi, and then we're going backwards to our arms. We're going to subtract that related acute angle, that reference angle, 2 pi minus 0.28. Sorry, it's 2 pi that is approximately 6.0. We want to express that that's not just rounded to 6, it's rounded to the 10th. And so there's an example of decimals are related acute angles of decimal. It's not just one of these special angles we've been looking at, but we can still solve this the same way we've been doing. So that's the end of this first lesson. There's a little bit on these secondary trig ratios as well. So we'll go over quickly those in case you've forgotten. Trigonometric ratios. So find the exact value of secant 5 pi over 4. So secant of x, that was the inverse of cosine of x. So it's 1 over cos of x. So cos was adjacent over hypotenuse. Secant is hypotenuse over adjacent. And looking at cast, 5 pi over 4, that's just past our pi quadrant, or the pi angle. So we're in this T quadrant, the bottom left quadrant. Cosine is negative, so that means secant is negative. And our related acute angle, to get back to pi, we're pi over 4 past pi right now. So we need to see negative secant of pi over 4. Cosine of pi over 4 was 1 over root 2. So secant of pi over 4 is the inverse of that, so it's root 2 over 1. So this is negative root 2. And that would be our final answer. Number 2, if cosecant of theta equals 1.2 and pi over 2 is less than or equal to theta is less than or equal to 3 pi over 2, find theta. So again, just a refresher, cosecant is 1 over sine. So this looks a lot like these problems that we did up here. So we need our related acute angle. So we're going to take the yeah, just one more step. So there's a couple ways we could approach it. Cosecant is 1.2 or 1.2 over 1. So sine is the inverse of that. So 1 over 1.2. Our related acute angle is going to be sine inverse of 1 over 1.2. So sine inverse of 1 divided by 1.2 is 0.9985 or 0.99. So related acute angle is 0.985. That angle has to be 0.985. Now we're only looking from pi over 2. Here was pi over 2 to 3 pi over 2. We're only looking at this left half. We can only find angles that are in there. And we need to know when cosecant theta is positive. So again, it follows sine. So it's only positive in this top left quadrant. So we need to see, for this arm here, that's going to be pi, or theta is going to equal pi minus 0.985, or 3.14 minus 0.985. If we're going to simplify it a bit, you can use the pi button in your calculator. That's going to give us approximately 2.16 radians. Sine's also positive in this quadrant, but this does not meet the criteria set out by our domain. So here we're only going to get one answer, unlike the previous two examples like this we looked at, because there's only one angle in this domain that's positive. Our last question, find the trig ratios indicated for an angle theta in starting position that passes through the point. Okay. Negative 15.8. Negative 15.8? Negative 15, negative 8, yes. So this point here, we're looking at the arm that passes through that point. Because we always go towards the x-axis, our angle is going to go that way as well. So this triangle, in the x-axis, we're moving over 15 units, and we're moving down 8 units. Our hypotenuse is going to be 15 squared plus 8 squared, or 225 plus 64, which is 289, and the square root of 289 is 17. So our hypotenuse is 17. Sine of this angle are opposite over hypotenuse. Opposite is 8, hypotenuse is 17, bottom left quadrant, sine is negative. cosine of theta is adjacent over hypotenuse. Again, we're negative. Tangent opposite over adjacent, and we're positive in that bottom left quadrant for tan. And it asks us to find trig ratios. It doesn't say the primary trig ratios, doesn't specify anything about secondary trig ratios. So we're going to find all of them. So corresponding with sine, we have cosecant, and it's the inverse of cosecant. So we're going to flip our fraction. We get negative 17 over 8. Secant theta is the inverse of cos. So we get negative 17 over 15. Cotangent theta is the inverse of tan, and we get 15 over 8. The last, so we found all of our trig ratios. It also says solve for theta. So sine of theta is negative 8 over 17. Our related acute angle, we're going to take the inverse sine of positive 8 over 17. We get 0.49 approximately. So that's a related acute angle. And because we're in our bottom left quadrant, we're going to do pi plus 0.49. So we go all the way to pi. We're adding that extra related acute angle. Pi plus 3.14 plus 0.49, 3.63. So theta equals 3.63 radians. And I believe that's the end of that question. So that was a little bit of a longer lesson. These are going to keep coming up throughout this week. Make sure you're keeping up to date, and please ask any questions you might have. For now, enjoy the rest of your day, and you'll hear from me again soon. Bye.